All right, so I'm running a little bit late today. I was getting a quick um, refresher on some topics with Milo before I started today, just to make sure that I was, up to date uh, with this stuff. Because I have to admit, even though I have been working pretty deeply with the signals stuff for years, I have been down a pretty specific tangent the last several months. I think many of you are aware. And sorry, my second monitor just crapped out the second I started the stream here. Give me a second here on this technical stuff. USB, no signal. That's lovely. Come on. All right. Is it back? All right. There we go. Sorry about that. Oh, okay. It's going to be fiddly today. That's lovely. Okay. All right. We're good. We're good. We're good. All right. Yeah, I'm streaming today at an earlier time than usual. Just changes. Have a new baby. Got kids to drive around to, etc. So yeah, almost fooled you with that background. Yeah, I fool everyone. I mean, it is my office. It's just my office from a different angle. So yeah, but um, green screens are fun. You can do stuff like this. Looks like anyway. How are we doing? Yeah, sorry, a little disorganized because it's been a while. It's been a month since I did the last stream, and this gives people some time to sign on. We get to let people get past their Twitch pre-roll because I'm sure all my Twitch subs have expired by now. So there's that as well. Let me actually pull up Twitch here, make sure I can interact with you guys in the chat. Yeah, Twitch chat is existent. All right. There we go. And we probably should let people know that we're live here. All right. I don't know if people like the thumbnail today. I had quite a few different references in it, so hope everyone got that. Obviously, the Alien from Resident Alien. I don't know if anybody watches that, but Alan Tudyk is hilarious. Big fan, always been. And then I took the logo from the Aliens movie. So it's all good. Anyway, I think I've wasted enough of your all's time to actually people join the stream. Looks like they completely updated StreamYard. Lovely. Okay, so to the topic today. Yeah, that's not it. That's not what I'm looking for. Let me see if do I have notes? Yeah, okay, got my notes. Okay. Sweet. I took a few because I wanted to, make sure that even though I admit this is about as much of a first look as possible, I was at least a little bit prepared for references. We're going to be talking about alien signals. We're going to talk about some View stuff, View Vapor. I just saw Evan's talk um, from View Conference. Might want to talk about that a bit because I think we're going to talk a lot about benchmarks today and the concept of performance. Um, because I think this is pretty important for people to understand, and I think it gets misconstrued all the time. I was someone who's suggesting that benchmarks are primarily a marketing thing, and I'm like, not by my book. I do everything by benchmark. There's actually, while I was away, there's some term like vibe coding that started showing up, and I was like, "What the hell is this vibe coding thing?" And I looked it up, and I mean, it makes a lot of sense, but it's kind of funny. It's like the exact opposite process to what I do. Like I sit there and write like a billion pages of notes and thoughts before I can figure out how to even approach the problem, and then I do tons and tons of benchmarks to decide if something's even viable. And then I go, okay, what can we do with this? Whereas, like, that's the opposite end where you're just like, I have an idea or a concept of an idea, and I'm just going to kind of guide my process until I find where it is. Um, yeah, it's like two opposite ends of the spectrum. One's very much a design product zone, and one's very much like a engineering, mechanical kind of zone. And I think both approaches are valuable, like top down, bottom up, for different kinds of problems. So it's kind of interesting. But I rely so much on benchmarks that when like the prospect that, you know, they're a marketing tool is just craziness to me. Anyway, I get it, but like we'll talk about through the course of the stream. You'll see what I'm talking about. I'm pretty sure. Anyway, yeah, it's nice to see everyone here. Yeah, sorry, I usually tell everyone to say hi in the stream at the beginning, and then I give people shout outs. You know, people like Aiden, Creator Million. You know, I know great people working on Solid, and yeah, I see a lot of regular people here. It's great to see you all. Sorry, I kind of was dealing with my technical issues. So just hello everyone. Great to see you. So, yeah. Sorry, did I already say hi to Greg? Hey, Greg. This is built by people who definitely are not vibe coding. Yeah. Yeah. Hello. Okay, so yeah, let's see if I can. It's probably been so long that my Mac's going to tell me that I need to like restart to share my screen. I, I'm not looking forward to this. Let's see if I can share my screen without it doing it. Oh, I can. What do you know? I can. Thank you. Okay. Yeah, I mean, I should have banners. I've been trying to keep up on like the subtitles. There's Jesse. I don't know if you guys know Jesse Pence. That's done an amazing job for over a year. Basically putting in timestamps for all our uh, streams. And then I took a lot of time off and spaces, and I think we kind of lost touch. So I've had to do the last few myself, and God, I do not enjoy doing that again. It was really important for me to do it for the Solid 2.0 signals stream, and it took me like 4 hours, yeah, like half a day to get all the timestamps in, and I haven't even got to doing them on Tanner's stream yet. So I mean, if I was smart, I'd add banners to kind of help with this, but I don't know. I think we're just gonna flow this organic. So here we go. It's funny, googling alien signals, and this is what I end up with. Let's get to it. First of all, I did not realize Aliens Signals was sponsored by StackBlitz. Apparently, the developer is sponsored by StackBlitz, which is kind of cool. Just an aside note, I love to see when startups help open source projects be able to, you know, help developers be able to do this. And I mean, it's important so that, you know, we can actually find important work to happen. What? Hey, what? Well, alien signals. Yeah, let's get started. What are alien signals? I think this is a perfect header. I don't need banners when I got DAX. More than this cute logo, they are a implementation of push-pull reactivity of signals, and inspired by many other projects apparently here. Let's look at the README here. Propagation algorithm based on Vue 3. Not really sure what that means. Maybe we'll find out. Preact doubly linked list approach or signal boosting. This I am a little bit familiar with, but if you're not, it's fine. We'll look into it a bit. Inner effect scheduling of Svelte. I've heard about this. I'm actually not super familiar with this one. And then the graph coloring approach of Reactively, which we have covered previously on stream. Milo, obviously solid core team member, wrote Reactively, and we had him as a guest at one point, and he wrote a great introductory article about Reactively and showing all the different ways of notifying, right? And so this is a bit outdated now, but it gives you a good idea. This blog post is still to this date one of the best reactive activity, like more advanced. Like I did that, how to write your own reactive library, a very basic one. It's not even, I feel like it's like good for teaching the concept, but it's like kind of almost a lie. Like 90% of the complication of reactive libraries and signals libraries is in the implementation of derived values, computeds or memos or whatever we want to call them. And when I make a reactive system in 30 lines of code or whatever, 40 lines of code, it basically just has signals and effects. It's just a pub sub that I've warped into has auto tracking, but warped into the shape of our signals libraries, where the real power is the way that stuff propagates through the graph. And he talks about this a bunch, talking about like versioning and reference counting, and these guys use versioning if I'm right, and then coloring. So it sounds like you use coloring Reactively. It sounds like the author has definitely learned from the different implementations. I remember, signal boosting. We should probably talk about this one a little bit. And this again is another good blog post. I never remember if I could say his name properly. Joking. I met him a couple times a couple years ago when he was working on this, when Preact signals implementation coming out, and he had a bunch of questions, and we kind of compared notes. And one of the big improvements in terms of performance that Preact signals made was how it handled managing the dependency graph, like the actual. It's not just the notification. Reactively focused on the propagation, but the actual data structures of how you actually hold the dependencies is an interesting problem. And I don't know how deep we want to get into this on the stream, but I mean, you guys are here and I'm here, so we can talk about this a little bit. But okay. Some people, when they get interested in signals, the first thing, you've heard of the Gang of Four and the observer pattern. Let's see if we can see here. This is the basis of all signals libraries. Knockout had it, and it was like established as one of the 23 well-known Gang of Four patterns. Right, there's a subject and an observer, and there's this relationship between the thing that listens and the thing that is being listened to, right? And the problem with the observer pattern in general, it's not a huge problem. We have ways to solve this, but it's like things that discouraged this in the past. Why, one of the many reasons why the React team doesn't like signals is that the life cycle of the observer and the observant, I don't know, use these terms, can differ, right? So if so what they say, the observer pattern can cause memory leaks known as lapsed listener problem because of basic implementation. It requires both explicit registration and explicit deregistration, as in the dispose pattern. And what they're talking about here is it's possible for the signal, like the source, the thing being observed, to outlive the thing listening to it. And over time, it just keep on collecting more observers that just fire off into space. No one cares, but you just keep on leaking memory. Observy. Observer and observy. Is that how we're going to call it? Okay. So the reality of how to solve this is you can't actually just hold the value in one direction. Like you can't just be like, I have because like the naive approach, and if you write this by hand when I talk about that 40 lines of code, actually, do I have this building a reactive library from scratch? Right. Okay. The naive approach is your signal is going to have its list of subscriptions, and then when you write to it, you're just going to go through that list and call it. But as I said, how you have a bunch of things listening. How do you make them unlisten, right? One of the things with the our typical auto tracking reactive systems is that you don't have to manually call subscribe, right? You just go effect, they're computed, and you just listen to the signal, and you're good to go. And there might be on the outside, like your effect might have like a stop or dispose kind of mechanism, but like generally speaking, how does that work? Well, the answer is you actually have to keep the references both ways. It's not just the signal or the observee or observable. You guys are great. Yeah, that needs to keep the list. It's actually the observer also has to keep the list of the things it listens to, and that way they can, like, when the observer goes, I'm done, it can go back to the things it listens to and goes, hey, unregister, 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 right? So it's kind of a fundamental problem that you actually have to link both directions. But if you link both directions, I think you guys should realize the consequence here is these things can't self-release. Like they the one reference the other reference one, as long as one exists, they basically have the potential of never being garbage collected. So yeah. I mean, why not subject? Because that's literally what the term they used when they were talking about it, the observer pattern. Why is this relevant? Well, it means that managing this list is always going to be a critical core bottleneck or piece of the performance when looking at signals. And in the past, like way back in the day, like you go back to like Knockout, this is a very simple setup. We just had arrays on both sides. And honestly, when we were tracking, we probably didn't dedupe, or at first people literally just kept on pushing stuff to arrays. And the problem is, like, they get kind of big. You just blow it out after every run and you just create these arrays. And if you listen 5 times, you'll have 5 entries and all this kind of stuff. And people did try and start doing smarter things. They would be like, whenever a new dependency come in, they'd be like, hey, is it already in this array? So you do like a find operation. Well, it turns out that's like really, really slow. If like every time you do some kind of tracking or some kind of update or something, you're sitting there and doing like, is this in the array? Is this in the array? Is this in the array? Is the array, if the array grows, or if you're just simply like asking the question over and over again, arrays are actually kind of slow. And this led to, and as I showed in our kind of basic example, people using sets when they were available. So sets were better because now you could just like make sure that it was in there once. And at the dawn of like Vue and MobX or that, this is kind of where they kind of came in. The problem is sets are fast for lookup, but they're slow for creation. They have this memory overhead. And as I said, when you're making a basic example, you're going to use sets. But the reality is it had a significant kind of performance overhead. To the point that when I was looking at reactive libraries, like I built my own with naive arrays and all this stuff. And when I started looking at how I was going to do stuff performantly, I looked at Vue, I looked at MobX and stuff. And I was like, okay, but then I realized, like, I saw other libraries that come out and they're way, way, way faster. I'm like, what's going on? And one particular library came out, and that was called SJS. And if you look back to SJS, it was actually created like in 2011 time period, like back in the original knockout days, kind of like went on its own parallel path. But SJS had kind of come up with a different approach. Instead of going to sets, they'd improve the array approach, which seems kind of crazy, but by adding more arrays, which is what they did was they added Milo affectionately calls it slotting. But the idea is not, you don't only store the items in an array, like the depths on both sides, the dependencies and the listeners, like you actually also store the index of where it is in the other's list. And as long as you have both pieces of information, both the observer and the index and the observer, you don't have to do those expensive find calls anymore. It doesn't stop from deduplicating entries, but it means that like on removal, you don't have to like go searching for it, which as I said, the buildup and removal was a very, very common thing here. So SJS drastically improved the performance of these reactive libraries at the time. And since then, there's been other approaches where it's like, oh, maybe we don't have to always reconstruct the list or whatever. Anyways, fast forward to the future. What Preact introduced was, what if instead of using an array or a set, we used a linked list? Right? And we look at the edges. And there's been lots of versions of this over time. And I think a lot of experimentation over the last 2 years has been actually understanding the implications, because a lot of them were actually like, did things that seemed good at first, like, oh, let's add versions on the edges and do this, all these kind of smarter propagation pieces. But then over time, I think what's kind of we've seen happen is people go, oh, actually not doing the thing that we thought would improve performance actually improves performance. Like, it's actually been a reductionary thing. And I mean, this is one of the things I love about SJS, because they just sort of like, we're not going to dedupe the array. Like, sometimes it's okay that things get added multiple times. It's faster than actually worrying about it. And this is where I'm gathering what we're seeing kind of come to fruition here with alien signals, where, like, I used to have a benchmark where I'd like try and compare all the different approaches. In Solid Repo, you'll see like the bench folder, and I had like all these different kind of propagation and different kind of patterns here. But over time, I actually had to break off a separate, what I call core version of Solid, because Solid had gotten so complicated with transitions and all this other reactivity stuff that I kind of had like a baseline version that I would mutate for my benchmark purposes that was different than what Solid actually used, but basically the same algorithm. So anyways, let's continue a bit more with alien steroids. We impose some constraints, such as not using array, set, map, and disallowing function recursion to ensure performance. I'm gathering they mean internally in terms of data structures, not in terms of what values you can hold inside the signals. I think I saw someone say, like, how is this at all useful if you can't use any of these? I think they actually mean that they don't use arrays, sets, or maps in terms of internally to prevent, this overhead. Yes, it's internal. Yeah, that makes sense, because I mean, you definitely want to be able to track arrays. That's pretty fundamental. Civility loss more significant occurrence within complex scheduling strategies. Well, we'll talk about this. I think then, yes, I think it is important. I think this is just a way of paraphrasing what I was saying a minute ago, that some of these like versioning or more complicated scheduling strategies actually are more expensive than coming up with the right way to store the data and just running it out that way. Even though Vue 3.4 is already optimized, the alien signal is still noticeably faster. Okay. Oh, come on. Really? I can't just open this image? Oh, okay. From the transitive bullshit. Yeah. It's funny. Milo reactively wrote this benchmark, but then it looks like when alien signals came out, someone forked it. I want to talk about this benchmark for a minute here, but we'll get there for a second. So basically, 3.4 switched to pull based, similar to Preact, and then wanted to continue the work. Like this has been probably the most exciting thing um about what's been going on recently is like people kind of get a taste for it and then they keep on they're like, oh, there's room to improve, they move the room to improve and room to improve. And I think we're probably getting to a pretty optimal place. I want to look at this in a minute, but then yeah, obviously Vue's using it. Okay, basic API. So we have signals, derived signals, effects. Yeah, straightforward. Effect scope. Cool. Okay, so right off the bat, this has effect scope, which if you've used Solid before is create root. Essentially, they add ownership like SJS. So already this is more than like a basic implementation. Like, and it has effects. Reactively doesn't actually have effects. So reactively was just signals and computed. So this is actually as a baseline. I don't know what I call signals 1.5. It has the ownership graph. It has the ability to. It has the effects, which means it has some amount of scheduling. And okay, and then yeah, create signals proposal. Blah blah blah. In order to eliminate recursive calls and performance, we record the last linked node on previous node to propagate the train and implement rollback logic to return the node. So in this code is difficult to understand. You don't necessarily get the same performance improvements in other languages, so we include the original. Well, that's nice. I like this. The mentality here appears to be like this algorithm should be implementable cross platforms. Like basically, they're like, look, we want. And I mean, I saw that above here when they were talking about like in Go, or Dart. So like there's definitely a desire here to keep this implementation generic. And it's very interesting to me that ownership has finally found its place as part of a core library. Like this is one of the things that I've been talking about for quite a long time, like because ownership is very, very important to how we do rendering in Solid. It was like basically the big advance that SJS added to these libraries about, as I said, about 13 years ago. But almost no signals libraries other than SJS through that decade until I guess like when Solid came out actually added ownership. And it's a very, very, it's now kind of like a keystone topic. It'd be weird to find a new signals library that didn't have a concept of ownership. I would think, but I don't think Preact signals have ownership. So I'm actually very stoked to actually see ownership as part of the implementation here. Yes, yeah. I mean, I'm not saying everything's on a single path. I mean, I'm just saying that SJS went on its own path. They used a different algorithm for arrays that was faster. Yeah. I mean, the funny thing is there's a lot of historically, there's been a lot of really powerful research in this area, but it just hasn't been mainstream. And now it's starting to be. So like, it's interesting to see like, like the implications that have like actually lots of people working on this. Like, I'm not going to lie. I would love to see a modern take on SJS in terms of this. Like this linked list approach might be fast, but I mean, there's different types of benchmarks. The thing that SJS nailed was creation time, and as everyone knows, linked lists are really good for in the middle updates. But I have to imagine that a slotted approach maybe would still be faster for creation if updated. Like I'm sure there's greater minds than me that could probably, make that happen. I'd be curious, we'll look at the benchmarks in a minute. I just want to kind of go around a little bit further. Yeah, is this the end of it? Okay, yeah. So this is the end of it. Yeah, no, I do think it's cool though, like that. The idea is this is something that could be implemented in any language. Yeah, So I mean, sets did not exist in 2011. Yes, I get what you're saying. I'm just saying like everyone was doing really dumb stuff with arrays. SJS was doing smart stuff with arrays, and then when the time came, most solutions moved to sets. SJS stayed on their smart solution. Wait, how did the linked list? Linked list is the hidden solution here. I believe so. Yeah, let's take a look. Let's now is probably a good time as any to take a look at the code and get an idea of what we're looking at here. So first thing I noticed, and this is what kind of made me want to cover it, like because people are like, oh, look at alien signals, look at alien signals. And I was like, it's faster. You'll see later in the stream why I'm like, but I think if you actually read the README, it's not about the speed. It's about this trying to simplify, or like, and I say simple not in the terms of like easy to understand necessarily, but in terms of like, I'm hoping like clearly defined, elegant code, because this is a very small a fairly small implementation. I looked at it and I was like, wow, index is literally the API surface. So like for the most part, you see it just importing stuff from system, and then what do we have here? Create reactive system. Okay. So this is where it injects tracking system. Yeah, like this is like the actual like run function, so to speak. Start tracking, try to do the thing, end tracking if value not equal. So if you want to add equality checkers or some other kind of thing, if his scope is notified. Interesting. I don't know what this means, but this has to do with propagation, pause stack, start batch, end batch. Okay. Pause track moving track. I always found it weird that the Vue community doesn't use an untrack function, and they have this like arbitrary like stop start. I mean, maybe because it's designed to be an internal API. I brought this up with Evan at one point, but like having you the pause or start without the beautiful thing about what untrack function is, it scopes the range at which this thing operates. You can't stop without forgetting. You don't have to reference count like how many stop calls or start calls. You know what I mean? Like conceptually, like if you're nesting, like you literally have created the scope. Now, that being said, you created a scope, so maybe the extra function call is a consideration here. But like there's lots of situations where, especially when you get these nested hierarchies, where you actually want like the reason that components are untracked and solid, or the top level of 4 iterations untracked, where you actually like when you're mapping over things, where you don't want to just track everything underneath, you actually want to like give the end user like, here's an untracked scope for you to work within. So like tracking and untrack is very fundamental. It's always been interesting to me. I mean, this is a thing, and you can build untrack using this, whereas using untrack you can't build this. So in the sense, you could say this is more fundamental, but it's also like kind of error prone if you expect end users to use it. The array index JSTRUCT you're talking about is sparse sets and used all the time in game dev. Yeah, I mean, I definitely can see it, and it's it'd be really funny if we see another bounce back around to that. I honestly always thought SJS was really on to something. Anyway, yeah, so signal, use bind it. Yeah, that's fine. Computed. Yeah, a lot. You'll see this a lot where this is just a sort of like side note. And when people ask about the TC39 signals thing, I want to kind of point this out to people. A lot of times when you see signals libraries, you're going to see something like this. You're going to see like some internal core system with like a lot of stuff. And then you're going to see this interface that's like some object being bound to some like specific accessor kind of thing. And the reason is that like the awkwardest thing about signals in general is internally, we always want access to more things than we want to expose externally as an API. So like it makes it adding signals to the platform actually a little bit challenging, because either you try and make them user friendly and you but which is kind of confusing if you have like a bunch of different concepts and you kind of like it gets a mess, or you kind of make them knowing that someone else will wrap them. And that's what most of the framework authors who worked on the signals proposal were doing. They're like, look, we want a primitive so it can be shared, so we can build them, like debugging into the browser, and kind of like the same kind of concept of propagation. We can use, the underlying C+ engine or whatever to improve performance and all these kind of aspects, but not as the API wrapper, because we understand like whether you're Svelte with runes and or views API or solids API or whatever, we understand that we don't want to expose like all these internal things, because the actual like signal node or React node underneath is like, it's got like 15 properties on it. It tends to be, I mean, this implementation might be different because of the link list. Maybe the link list or the links actually carry some of the properties with it. But my point is, like, I think it's pretty common to see like this surface face over the actual implementation. So the issue is a lot of the time L1 through cache inline arrays until you get into the thousands is faster than sets. ON depends on node. The real problem in JS, you have no control over the underlying arrays. Fair. Yeah, I mean, it's kind of interesting though, because you don't actually expect to get into the thousands in the case of depths. Most signals or like computed parts of the nodes on the graph are going to have like one depth. Most. Although I guess the reverse isn't true. What you find in UI is that you fan out pretty rapidly, but like each of the fan outs might depend on one thing or two things, like a low number of things. But inversely, the source is dependent on by maybe 1,000 things. So yeah, maybe it'd be interesting if different sides of the edge were optimized for different things. Anyways, it's just a thing. I've been looking around the UI and to do real time SJS. Interesting. Okay. I mean, it's hard to say. And one thing that I've been finding a lot, especially working Solid, which is confusing, because we have debug tools. I don't know if you've seen the dev tools for Solid, because we didn't have components, right, or a VDOM. We've been in this sort of ownership graph thing for our whole existence, basically, And so our dev tools actually show you the whole ownership and reactive graph. You can actually see the whole thing, like in terms of like, reactivity, but it's like a bit like walking into the matrix where like, all the green numbers are coming down the screen. Like there's so many things, and like some constructs are composed of other constructs. Like if you look at like control flows or like suspense or stuff, you might, or air bounds, you might have like 5 of these things working in tandem with each other. So like the graph gets kind of complicated to kind of go like translate like this single concept into like, multiple primitive nodes that talk to each other. So yeah, I'm honestly not sure, but there are certain characteristics that you can see emerge in programs simply from the shape of the problem, so to speak. I can't tell you how many because that would scale with the size, but you can tell kind of by the shape. Okay. Getter, bind the getter, that makes sense. Effect. Yeah, and then here, yeah, you can see the ownership here, right? We have sub. Yeah, okay. Oh, sorry. So this is tracking, and then this is tracking and scope. Yeah. So they call scope, I think, is ownership, and then they call sub dependencies, if I'm understanding this. If you look in, you can always tell a library. Yes, the active sub, active scope. There's always a global variable in reactive libraries, and the common one that we always first learn about is the listener or subscriber or whatever. They call them subs, observer, whatever you want to call this term. But you can tell when something has ownership because there's a second one. We call it owner. They call it scope. But same kind of concept. Do you have any updates that you said? Honestly, I used to go to the meetings like I like we had a public meeting every second Tuesday, and then we had an internal meeting every second Tuesday. Once we put the original proposal out, after about 2 months, most of us stopped going to those meetings. I sat in a couple of the public ones and I kept the private ones. I had some like interesting chats with some other framework authors, especially, and then the public one trying to like gauge people's interest and understanding. Like they're still going. People are still pushing it forward. What I was talking about was basically the starting point when we recognized this almost within the first week of the framework authors getting together before the proposal was even pushed out there. It was kind of interesting because other previous observable like for RX style observable proposals had all been about interop. It was all about the public API service, right? Because you have operators that need to operate. So we had like Ben Lesh in there, and he was really wanting this to be a user friendly mechanism. And he was like, it's all about interface, like symbol, signal, or whatever, like that kind of mentality. And he was kind of outnumbered. And I think after a week or so or two, he was like, I think he got in, and he kind of changed boat on our side. And he was like, yeah, okay, yeah, that makes sense. And kind of got there because of like, you talk to Misco about presumability and its needs. You need access to internal parts of the graph. You can't just like hide it. But on the other hand, nobody wants to give that to the end user. So, like it's awkward. So yeah, most of those discussions were behind closed doors. It's why the proposal was made the way they were. I know that there's been discussions like that since in it, because like when the web component and lit people and all of them came in, they're just like, same thing again. They're like, why doesn't this just work as an end user API? It's because like it's tricky. And if you have like, this is designed to implement a system. It's not designed to have like every different web component have their own reactive system all sit next to each other and have their own thing, because you kind of want the schedulers to play nicely together. But we didn't want to include scheduling because we didn't want to make too many assumptions on how scheduling should work. So it's like, because even across the frameworks, we couldn't decide on that. So like, yeah, I mean, this one's interesting. I hope that we can keep the scope small enough that we can find real value on it. But it's always very challenging when people who like web components are involved. Anyway, sorry, where was I? Okay, a lot of standard questions here, but I'll answer one. Do you think it's worth doing the standard? The benefit here is potentially worthwhile. There could be performance improvement, which is key, but the key thing that I'm actually excited about is, think about async await in the browser, right? You can see async stack traces in the dev tools. Like you can actually walk through it when you hit an await and continue on the other side in terms of debugging. Signal's debuggability is one of the challenges we have because it's an observer pattern. Things can fire all over the place. MobX has done an amazing job on this kind of tracking. They actually like almost make their own call stacks. But picture if, because this was core, this is part of the JavaScript, we could actually trace reactivity in the same sort of way. I had talked a lot with the guys from Replay about potential doing this, like time travel, like moving back and forth between reactivity, because there's the challenge with the reactive system is, while there's a cause and an effect, when you're actually tracing through the code that runs, the causality is completely lost. It goes from being like thing happens over here to like whatever linked list propagation, scheduling, whatever notification, coloring, whatever thing, to something over here executing. And as someone trying to debug that gap, it's increasingly difficult to actually like piece it together. It would be amazing if that was just something that you could do in the browser. That's my biggest sell. I mean, I understand there's a lot of complications and a lot of other pieces. I'm constantly concerned about the impact of future APIs. Like the standard doesn't have scheduling. It doesn't have ownership. You want to make sure that ownership's part of it. I think everyone kind of now agrees that ownership's an important part. Well, what about async? Again, this is an area that's, very important to me right now, but I don't know, it's going to take time. We're still learning this stuff. And the worst thing you can do is put in something to standards that is not ready. Otherwise you get stuck with it, and then you're kind of stuck, as again, like web components. Yeah. Okay. Computed, notify, scope. Anyways, on the surface area, effect stop, start tracking and tracking. That's interesting. Oh, that's so clever. Sorry, this is just a funny thing. Do you understand what this is doing? It 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 it's reusing the internal cleanup mechanism, because what it's doing is it's starting tracking, then it's ending tracking. It's for this node, which I guess is an argument for the. Oh no, but this is pause and resume. I hope you get what this is doing. It's basically saying, hey, start tracking on this node, and then don't track anything and end it, which means it automatically disposed of its dependencies because they created it runtime. I'm gathering that's what this does. It's kind of cute. Getting into Vue and people trying different stuff. People were looking for that de facto signals library for a while. In fact, people were pressuring me for a while. They're like, "Oh, you should release solid signals," and I was like, "It's not that good. Like, I mean, it's fine, but I hacked together what I needed at the time." You have to understand, like, when I wrote solid signals implementation, it was after I'd kind of migrated from the SJS one. It was like 7 years ago. Like, it was fast. It wasn't as fast as SJS. I needed features that SJS didn't have, and it slowed it down. But like at that time, most implementations were actually all really, really slow, so I didn't really care about it. But I think people have been like, after Preact and all this new thing, people are looking for the de facto push pull stuff, and I think we're finally getting to where this is a very reasonable base for reactivity as we know it yesterday or up to today, so to speak. Right? Like that's what I'm gathering. Well, like the interface here side isn't that interesting. So let's look at the system here. And I think the first thing that come out is this is about 500 lines of code. So, and there's comments and stuff, and like this is not a big implementation, which is cool. So let's take a quick look here. As I said, I'm not an expert on this on any hand, but just this is my first look. So let's like look into it. So yeah, it's interesting the reactive system has the run and I guess the notify mechanism injectable. I think that's smart. And then it uses that to build the rest of the stuff out. Okay, and what do we got here? Link. Links a given dependency subscriber if they're not already linked. Fair enough. And this is just like typical. I don't know how they do it, but depths tail, subs tail. Yeah, so are they, I guess maybe they're using like the same. Are there, yeah, there's two lists. Yeah, there's a depth link list and a sub link list. And then they're basically just doing link list operations of appending. Okay. Propagate. Flag should notify recursed is valid. Okay. Interesting. There's recursed and propagated. So I'm gathering there's some optimizations in here in terms of flags. I'm not used to seeing necessarily all those like notify tracking. Okay. There's more flags here than I'm used to in terms of the basic pending effect pending. Okay. Yeah. Because there's always like, usually like with coloration, there's and even version 2 there's the definitely dirty and the could be dirty and clean. There's like 3 states typically on a reactive system, right? Because when you propagate through the list in the push pull system, you need to actually notify everyone at the end. So you have to go through, and the thing at the beginning is definitely dirty, but all the way between that and when you actually pull it all the way through, the thing may or may not be dirty. If you assume that it's dirty, that's the problem with push only algorithms. They kind of have to. Well, I mean, it's not really the problem with them. I mean, their problem is over execution. The problem with push is that like you basically go down and you execute as you go down. And the good thing is if you ever hit something doesn't update, you shortcut and you're done there. But you can't see the whole graph. When you do pull algorithms and you assume everything's dirty without the push, like React, you basically have to re-execute everything. Sure, you can memoize, shortcut it, but you basically have to check every single thing and be like, okay, I can't stop early. Push pull has some of both characteristics where you push through and you go, okay, this stuff's dirty. The rest of it could be dirty. You get to the bottom and you go, okay, now I'm going to ask. And you go back up and you go up the tree and you go, okay, all the way till something's dirty. And then you start working your way down. and the benefit of this is if something later comes across and gets to a certain point and sees that thing's dirty, it doesn't have to go any further up. It only has to go up to the thing that's dirty that it needs to evaluate. And so you do kind of save doing the work twice that fixes push. But on the other hand, because you only notified the things that could possibly be dirty, unlike React, you don't have to re-render everything, essentially, right? So it's kind of a bit of both. It's interesting that there's many more subscriber states here. I think someone actually sent on, let me see if I may want to pull Discord out off the main screen, but I think something was shared with on online. Let me see if I can, let's see if we us on stream can make any sense of this. Yeah. What from the author himself. I actually was hoping to get Johnson on stream, but I couldn't get that to happen. But this beauty was shared with me. Yeah, I mean, looking at the amount of code, I imagine that the solution is incredibly elegant and direct, but hard to follow. Because I'm looking at this and I'm like, this is a system with 2 signals and 2 effects, if I understand. But I couldn't tell you for the life of me what's happening here. Kristen 720p. Can I blow this up a bit? Yeah, maybe this is a little bit better, but yeah, maybe we'll have to get Johnson on himself to actually explain what's going on here. I mean, obviously depth, subtail, depth tail. Yeah, I'm not even gonna take a guess at what this means, and which is probably unfortunate for a bunch of you who were looking for that expert thing. As I said, I called this the first look. I feel like I'm gonna have to get a little deeper to make sense of this, and not in the timeline that I'm looking at here. Okay. 5D scale drawing, like an alien spaceship. That's exactly why they made it this shape. It's like a UFO. See, it's like the bottom part of this thing, and they sit up here and look through this window. Yeah. Anyway. Okay. See, let's continue here for a minute, okay? Because yeah, I'm looking here at propagate, and I recognize the high level stuff like should notify, if should notify, but yeah, branch depth. Yeah, there's some stuff, right? Start tracking, that's makes sense, and tracking. It's interesting because we've been using linked lists as our ownership tree for Solid 2.0, not for our depths. Like basically, I took reactively and then added linked lists for ownership. So like some of the code has similarities, but I think the depth part is very interesting because it's like unless you're like really following like the linked list thing, all the processes are just become a function of the linked list, right? You're like, okay, like instead of being like, oh, for something in array, you're now like going like, okay, what's going here? Get the depth, go there, next step. It's just kind of interesting. I'm not gonna lie. Obviously, I'm not gonna write out the algorithm here and figure out how it works at this point. I wanted to see high level what I was looking at, and high level, I think what's really clever here, because I'm almost at the end of the file. Yeah, I'm basically there is valid link. Yeah, clear tracking. Yeah, okay. Is all the code is linked list code. Like, I think what makes this solution so simple and elegant in a sense is that every single function is just a function of working on this the set of linked lists, both the ownership graph and the dependencies and the subscribers, like both sides. So like everything just gets boiled down to linked list operations, which is probably really hard for the layman to follow, but on the other hand, means that like essentially there's no other code. It's just like the whole question is like, how do I put this data structure together? It's completely data structure driven, which is like incredibly cool and apparently incredibly fast. Yeah. Yeah. I mean, yeah, there's a lot of flags. Well, the thing is, Milo was talks to Johnson, I guess, a bit, and was like, it looks like got him to implement alien signals using slots like SJS. You know, just something these kind of guys do for fun. And see here's system TS with slots apparently. Maybe this will make more sense to us. Computed, effect, tracking, notified, recursion, dirty, pending. Okay. So how is this different if we use slots instead of linked lists? Okay, I mean, depth, length, add length, sub slots, depth slots. This is what I'm talking about. Where so yeah, keeping track. It's interesting. Oh, it's because you keep track of the. You can't because the. I guess because the array can be holy. You don't want to keep. You keep reference to the length rather than like using the array's own length. But essentially, subs, depths, subslots, depth slots. So like the double arrays on both sides. It's interesting to see that if the propagation could be done in the same sort of way. It's funny, the code's a little bit shorter there, not implemented. Okay, yeah. So this is just kind of like a concept, proof of concept. Very cool to see them playing with this. It shows a great understanding of the different reactivity systems in general. Um, Milo also sent along a benchmark. Let's see if I can, maybe I can open this in a browser. Why am I not? Sorry, give me 2 seconds. Usually when I open stuff in Discord, it just says like open link. Bang. Okay, here we go. Oh, I mean, alien signals recursive calls with slots, and then solid 1.0, which is like obviously by comparison. But alien, yeah, it looks like the slots here are generally a bit are generally slower. Seeing here, I wonder if this is fully optimized for something just whipped up. That's interesting. Anyways, oh, apparently we have an updated one. Just a second. Open link. These guys are like working like 24/7. I don't even know what. Oh, okay. Yeah, this is different. Yeah, okay. Oh, with one placeholder slots. Okay, this performance is much better. Slots are slower than the current alien signal solution in most cases. Not all cases, though. I will point something out. I actually think in this benchmark, I don't know if you guys can see this, but create data signals like from here to almost the end. This is the SJS benchmark, and the SJS benchmark is broken in these libraries. I went to go test stuff with Solid 2.0, and I was like, wait, this isn't comparing to 1.0. And I'm like, wait, this is not actually working because SJS assumed everything was synchronous, and almost every single system isn't synchronous now. So it's like basically they're not measuring the thing. This benchmark was all about creation times. It's why I always felt it was the most representative of like real world rendering. And Solid's like off the charts here. It's because like literally Solid's work is being measured, and these guys are just like calling a function, and then the measurement ends before they do any of the work. Um, I talked to Milo about actually fixing this because it's my favorite reactivity benchmark, and it like actually doesn't work with any of the current libraries. It's kind of interesting how people reference this what do you call it, the JS reactivity benchmark all over the place, but there's actually like there are a few specifically with this one benchmark. There's actually like issues that make it not actually accurate. Anyways, sorry, let's get back to where we were. Yeah, I mean the thing is, there's this desire to. Yeah, I mean, I think this is. I mean, you're don't ruin my whole stream for me here, but I'm we're getting there. I have to build up the importance of yeah, exactly. Which is making the benchmark kind of not make any sense. So yeah, I mean, it's definitely really interesting. Let's actually look at those benchmarks now, because as I mentioned before, Milo created the original benchmark and he posted it way back and he showed the results and um originally it was like his tests, which you can see the scaling kind of go on there, and then when you get to the, you can see it right here when you get to the tests for the SJS, everybody's like the same except like there's yeah, like I don't know, something's just not. Anyway, in let's the thing is, this is not the version of the benchmark that most people have seen now because Alien Signals isn't in it. Someone cloned his repo and added uh Milo and added Alien Signals. And I think this is the one that everyone saw for a while because this kicked up a bunch of things because there's like Alien Signals and then Reactively, which Milo's library, and Svelte 5 right next to it. SGS still very fast. 14 years later, OB, Mol, Preact Signals, uSignal, Solids implementation, Signia, MobX, Vue reactivity, TC39 Angular. Everyone give them a hard time. My understanding is that the performance here has improved significantly, but and the benchmark's been updated. But this was the thing that got everyone's attention. They were like, "Wow, what is this Alien Signals thing edging out reactively? We thought reactively was the fastest, you know." Um, and it it is interesting that we're kind of getting to like this point where like no one, we didn't actually think this sort of improvement was possible, honestly, for a while there. For those who don't know, Solid 2.0 is built on reactively. It is slower than reactively because we add a bunch of stuff. The same way that Solid SJS is Solid JS was built on SJS and is slower than SJS because of the extended capabilities of our reactive system. But you know, Alien Signals being faster is interesting because if you can improve the baseline performance, you know, maybe that could actually impact other things. That's sort of the question, right? So yeah, I mean, I don't know. As I said, the benchmarks need a little bit of work. Milo has told me that he is working on it, so to speak. He's actually been. When we get Milo is always tricky because he's in university. So part of the year he's very active. The other part of the year he's doing a lot of other stuff as well as his schoolwork. So it's tricky. I don't know if he's been he's been working with companies, advising them on their reactive solutions. I think he's been working with like Google and the Angular team a bit too. So it's almost summertime, so I'm expecting some. We might see some movement coming here pretty quick. But anyway, back to Alien Signals. Impressions. I think it's very, very, very cool when performance can be improved in a marked way. As many of you know, though, I've been a little bit skeptical of the value of this performance improvement, right? I think, I said, I think that the value is if you can create an implementation that's fast in all different languages and is straightforward to implement so that everyone can just like copy this and post it and it's small, I think that value it outweighs the performance value. Just to have like this baseline, like, so I think that's more the interesting part. And it does, because I told you guys at the beginning of the stream, that's how I build. I start working on something, and if it isn't fast enough, it's not worth doing. We have to rethink it. We have to approach it a different way. I'm actually going to have an example of that a little bit later in the stream. I want to talk about deep tracking in stores, which is an interesting problem that I just solved this week. Since coming back, it was actually Vue inspired. We're doing a lot of Vue stuff today. But before we get to that, I want to continue the discussion on alien signals. What I'm not clear about are the trade-offs. Well, I don't think there are many here as a base level. This is just smaller and faster. It seems there might be like some behavior differences people aren't accustomed to. Everything has this little thing, but at the baseline, I mean, Vue's betting on this. It seems like it's just an improvement in terms of internal algorithm piece. As I said, this is not where I've been, because I've been literally taking something and butchering the hell out of it to make it work with async, and then I'm gonna get to performance again, so to speak. Apparently I completely killed Reactively's performance with my async work. Not complete, but the funniest thing is it didn't kill its performance. It killed its performance in the JS reactivity benchmark, but it didn't kill its performance in the JS framework benchmark. In fact, Solid 2.0 is faster in the JS framework benchmark, even though the reactivity was slower in the reactivity benchmark. So, it's kind of I want to. Yeah, how much you trust the benchmark? This one, some of the tests are. It's a combination. If you, I mean, let's look at what's in this benchmark again, because there's basically, it's a combination of 5 different benchmarks. Sorry, I already had it open. I don't know if they're all in here, but the first set of benches up here at the top that Milo wrote, I trust, and they're pretty good. The CellX ones are kind of a waste of time. They test depth. That they work. There's nothing functionally wrong with them, but they also are like almost completely useless from a like we don't see 5,000 20. We rarely see 1,000 depth. That's like picking having computers of computers of computers of computers of computers down 1,000 layers. Like, you're more likely to have maybe a depth of like 5. You might have like 1,000 of those. There's a few threads that might have, but you're not. Yeah, like, ownership will break this apart naturally. You're not, like, generally speaking, you're going to rerun subsections of things. You're not going to like basically chain. You have nested stuff, but you're not going to like chain a derivation tree for 1,000. So, as I said, this benchmark this is the one that Preact guys like to always use, and it's almost useless. Like, if there was CellX 100, that would be like a decent place, because then you'd be like, okay, this is an over exaggeration, and like, this is good to test, like, because you always exaggerate with benchmarks. You're always going to go over the top to try and like push the extremes, right? So that you can say, like, on this particular vector, how hard can we drive it? This is like 2 orders of magnitude past usefulness. This is like if someone took the JS framework benchmark and was like, let's put 1,000,000 rows in that table. Like, that's never happening, right? And then this the mall benchmark is interesting. I trust Ninjin's work, so I think this one is probably relevant. This next set here, avoid propagation, is from Kairos, which used to be the fastest reactive system. This one is pretty good. And then the SJS one is my absolute favorite down here, except for the fact that it's basically broken with the current slew of libraries. So you can't really trust this one at all, which is almost half the test on the thing. So like, there's a mixture of like useful tests that are accurate, useless tests that are accurate, and then not accurate tests. So yeah, this one's a bit of this one's a bit of a mixed bag from my perspective. Well, that's the funniest thing. In when you run the Celex benchmark in StackBlitz, you actually had to deal with the Stack Overflow. Depending on like, there's a bunch of libraries that can't run it because the way that they do their system uses recursion, and the stack gets too high, and StackBlitz actually Code Sandbox actually dies on the Celex benchmark. Obviously, Celex doesn't because they wrote theirs in a way that doesn't use recursive functions. So you can argue like that's a win for them, but it's also kind of like, what, I mean, there might be a problem space where you need that, but that's not within the realm of like anything that remotely matters in like typical application building. If I'm a part of the JS framework, actually hold meaning in real cases, GEO section of the test are useful. Yeah, okay. Well, and this is what I'm going to get to, because like, let's talk about if we're going to say like, okay, I think we can conclusively say through the suite of tests that Alien Signals is probably the fastest performant approach right now. I think this is a fair thing to say. I think that there's enough accuracy in enough of these tests that we can actually say like it's pretty sweet, you know. But what impact does that have outside of this micro benchmark, right? Let's go up the next level. So yeah, JS Framework benchmark comes to mind, right? And it's funny because this question of what part of the benchmarks interesting or useful is a tricky one, because for those who are aware, there are several benchmarks on the performance side. There's 1, 2, I think there's 9 if I remember correctly, and I wish I could hide the ones that are quote unquote breaking the rules or cheating, because they basically just are native DOM. Like, you can always do faster by just like updating the DOM with vanilla.js. Like, you can always just like skip the declarative part of it. These ones should, you know, be gone. But like what you'll see generally speaking in performance wise here is we got Svelte. Oh yeah, Svelte's ahead of Vapor here. Solid's this run is behind them. Last time we were on stream, Solid was ahead of Svelte. Basically anything from about where Molina is here at 109 to about, I want to say, Wasm Bindgen. More Sinuous. I'll say Sinuous here. I could even count Vue, RX, JSX. Anything in this zone up here, basically, there's enough variance in the test that their positions can swap thing to thing. The value here is when you look at the specific things where you're like, okay, Solid's faster at select row, but has this performance overhead that the others up here, you can see it's on releasing on clear rows. In fact, this is one of the biggest, this is the improvement we made in 2.0 by using Reactively. We solved the performance overhead releasing. Solid has one of the worst cleanup performances out of any of the frameworks that are in the top lit, basically until we hit, no, even lit, yeah, in the top like 20 or 30 frameworks. Solid has, this is like one of our weakest points. Of course, any one of these single factors on a single test, because the weighted geometric means basically moves the number like 0.01. So that kind of difference ends up making less of difference in the variance of the tests themselves. So let's getting back to what these tests are valued for. Crate rows, obviously, create a bunch of rows. So it's a creation operation. There should be at least one. There's also create many rows, 10,000 rows. These things are similar but slightly different. There is the obviously like raw creation code timing, which adding nodes, bindings, all that, but it's also a memory overhead consideration. Mostly this is where you will feel memory pressure, especially when you get to 10,000, and especially with this other one where we append. The appending is not a expensive diff operation because you can literally but it's still, you have a big list and you add a list to it. It does test the diffing and the creation a bit. So these are distinct cases. And small versus large create many does have different memory pressure. So I think it's worth testing both of those. Replace rows, again, this is testing both the creation and the removal at the same time. Fairly typical operation. I think it's a reasonable one. A lot of these tests are creation based. That's why I was saying the SJS test was most indicative of this. Okay, partial update. This one is an important category because this is like when you have a granular change, like you're updating the text in one row or multiple rows. This is your typical fine-grained test because you have multiple different data sources that are propagated through your data. So if you have like everybody has a name and you add an exclamation mark to the end of the name, on every 10th row or whatever, that's what this does, every 10th row, then it's going to update in those 10 distinct places. Like if you're in a signals library and you have nested signals or stores, or, kind of thing, or reactive in view or whatever the hell you call it, you could possibly just update those single spots without re-rendering the list. For React, as you know, you re-render the whole list and then you diff it and then you decide it. So there's a conceptual difference here. Don't get me wrong, React's pretty fast at that. Do you know what's a fun little side note here? Look where Inferno is right here. I was talking about Vue Vapor and Svelte. Inferno, which has not been changed in like 5 years, was farther back in the past, but browser is this run up here. To be fair, Inferno is in the same category of performance as the rest of these, because not from its doing, but because the way the browser has changed over time. Inferno's actually got better in performance. Interesting. Anyways, but we're at a point now where this whole front of the list is basically interchangeable. Especially, as I said, like even up to, I'd say like MobX, JSX, like this range up to 1.1. The first, if you ignore basically the first 0.05 that are basically all cheating, you'll see Mikado here, which is marked as not cheating, or like, but they are actually kind of cheating. This is contentious, but the Molina today is the fastest as far as I'm concerned. But basically, this range of from 1.09 up to about 1.15 is basically interchangeable at this point. And we've kind of hit a wall, and we hit that wall a long time ago. We hit that wall 7 years ago. Yeah, it takes one to know one. Okay, do you want to know? Do you want to know what he's referring to? Let's see if I can. Sorry, let me change how I share my screen. Give me 2 seconds. I think this is worth calling out here. Let's present. Give me 2 seconds. And actually, I want to get the actual share screen Chrome tab. I want to get the whole JS World talk, not just my clip. Sorry, give me 2 seconds. Let's see. I think this is worth, if we're going to talk about the JS Framework benchmark, we should talk about this on stream, I think. Give me a second. I've been kind of away for a month, so I'm sorry if this comes like the thread is stale, so to speak. But I shared this on Twitter when I saw it. But let me see. Someone, I think it was Burke, shared this with me. All right. Okay. Beautiful. Okay. Let me share. Sorry, if I want to share audio, I need to share my screen this way. So give me 2 seconds. Okay. You guys ready? Yeah, honestly, if people like sub, the whole game, it helps the stream a ton. Um, yeah. Sorry. So there's a mention here that Wasm BindGen is not a reactive library. Yeah, it's basically vanilla JS for Rust. So technically, sorry, that one is it'll have 772 next to it. It's like cheating because it's not cheating. It just means that it's not actually testing the thing the test checks. And yes, we're gonna get there in a minute. This is where I'm getting to. So yeah, let's watch this.
A final release in 3.6, and the nice thing is,
can you hear this? Like, was the audio working?
we're actually not doing any benchmark-specific optimizations. For example, Solid.js is really, really fast in this select role benchmark here. And you can see both Vapor and Svelte is relatively slow in this one. This is actually because vanilla.js uses imperative DOM manipulation. So when you select a single item in a really, really long list, it's just one line of code. But when you write declarative templates, we still have to loop through the whole thing to figure out which one is selected. Solid actually kind of cheats a little bit by using something called create selector.
That's a little bit
optimization that's basically specifically just for optimizing this specific entry in the benchmark. We can do something similar, but we choose not to because we still beat Solid in this case without even doing it. And another important thing, like I said, is Virtual DOM Vapor.
Because we beat Solid without doing it. But this is people. I cut that last bit off on the Twitter thread because I wanted to be nice. But that's the same mentality that is propagating the problem, right? Like, because like the results are the same. Like, if you look at the when he ran it locally on his computer, Solid's faster than Svelte on this run, and Vue Vapor's up front. As we know today, Svelte is faster than Vue Vapor. It's not because Svelte has changed. It's literally run dependent. No one is particularly faster. We have two libraries that have slightly slower select rows versus one slightly slower than this. And even when you add Solid 2.0 out, which fixes this, it's still within the variation. We're talking about libraries shaving point like 2 or 0.3 or maybe 0.5 of a millisecond off a specific slowed down JS operation. In fact, Evan knows this, right? Because I made some call about, been cheating for 7 years. I guess I took to Solid. Like, I did this 7 years ago when I created Solid, right? Like this implementation. And do you know where I got create selector from? I was working. Sorry, I'm going to change how I'm sharing my screen. I was working at a startup that built imaging, an image, kind of like an Instagram / Google Photos for schools, and we had giant, image grids, infinite scrolling, multi-select, drag and drop, and they weren't just square, like simple let CSS do, and they used a justified grid scroll. So like the images actually fit width based on the height. And like we also did some stuff that was like Pinterest style, where we did the masonry grid. So we did a lot of like grid layouts with multi-select and with drag and drop, and the selection context could also be injected because different permission sets, different capabilities on different pages on those grids. So like you had all these different, like, some triggered modals and different workflows, wizards, like all these different processes around managing large grids of images. So it was that real world experience where create selector came from. So it was like kind of obvious to me that this was a problem that I need to solve. Like, selection is getting back to the JS framework benchmark, is a different category than partial update, because partial update you have data in each row. Selection's interesting because the data isn't owned for the row. Now, some people, and I don't know if this is marked as cheating on here, it might be, it's like 801 or something. It's possible to put the selected data on, like say is selected on each row. that is faster than just having a single selected. Like if anyone's seen the code for the JS framework benchmark, let's pull that up just so you can get an idea here. Is let's just pick, it doesn't really matter what implementation I pull up. I could just pull up Solid because or React hooks, sure. Let's look at React hooks. React hooks is fine. Most people know React. The point is, partial update is built based on, where's it, main job button, a row. Because essentially you have an item label and you update it. So every row has its own label and you update that label, right? Whereas selection is based on, am I selected, show this class versus the other class. So the idea here is that essentially there's a single selected state that gets projected onto the rest of the data structure. So you basically have to like, I don't know what the term is. There's probably a better comp sci term. This is not what a projection is. Someone told me, but this idea that you basically have a single source and you actually have to spread it out onto the rest of the data structure. And there are many problems in UI and in software that resemble this shape or pattern. So much so that in Solid 2.0, we have a primitive specifically for this. Like Trait Selector is like a slightly narrower version, I admit. But this was so important to me that we actually are shipping this as a baseline because it's a whole category of reactivity. And I've done 2 streams actually on this topic specifically, I think at this point. Sorry. It's not this here. Let me get back about the whole idea of mutable derivations and whatever. And one stream to explain the idea, another stream to show how we've effectively implemented it. But this is a category, just on a side, that I don't think people should sleep on. So anyways, just we see this every day, like when you have indexes being pushed onto an array, or I have a bunch of examples in this article. But the core of it is essentially is if you have this kind of grid, and signals are kind of immutable, and derived signals computed are kind of immutable. You basically give a function, you put input in, you get function out. It's kind of pure functions approach. But stores with their nesting aren't immutable anymore because you can change things lower down without notifying the thing above. And I was like, why isn't there a mutable derived primitive? I think projections, even if not as commonly used, are as core as, say, refs if you're in Vue, and reactive if you're in Vue, and computeds, or if you're, these concepts are in all the reactive libraries now. They just don't implement this. So yeah, I mean, I was a little tongue in cheek here. I'm like, if it took them 7 years to realize that, Solid was cheating, how many years is it going to take for them to realize that the view of reactivity, is missing part of the picture? But it's fine. I'm not gonna stress too much about this. I just what I'm getting at is like there is more to reactivity than what we've done to now. We're like at the beginning of this journey. It's so exciting to have so many people along with us. So we have different people working on different parts of the problem, and something like alien signals being able to work on like really refining the performance on optimizing the very baseline core is absolutely amazing and absolutely needed, because honestly, as I said, a lot of my stuff's a mess. Linked signal is the left side sync headers memo. Yes, it is. Yes. They call them linked signals. In Solid, we literally just added a function thing to the thing. This is something that, yeah, we talked about it in that article, the linked signal concept. It's something that I kind of first proposed about 3 or 4 years ago. It just took me so long to get it out. But I think, yes, they're writable memos, but technically speaking, they're still atomic. Like they're still like they're still immutable data structures. Like they're in the sense that like signals are. We're at the beginning of the best friends. Yeah, thank you. I mean, I've been trying to set those milestones. If you've been watching my streams, I think the work around both mutable reactivity and async are in their infancy, and I think there's a lot more to go. As I said, I'm very excited about it. Right. I think there's. I mean, we did this part of the conversation. The API isn't really relevant because people are going to wrap stuff anyways, right? There's this alien signals use the dot value thing. That's the only thing I can say. The frameworks that use dot value are just actually wrong, straight up. It's fine, but they are. It's just yeah. I mean, people are not going to agree on the API shape. There is a mechanical reason why dot value. There's a performance reason why dot value is right, and a TypeScript reason that's arguable. But the TypeScript reason is incidental. The mechanical thing is fair because dot value lets you use the prototype, so like it's can be more performant. But from a composition API standpoint, functions are superior. Or like what Svelte does, where there's no function and it's just a variable. Like technically, but the problem with that is obviously that they're just hiding that there's functions. So the second you transport it, you need functions. So then, I'm sorry, like you're not actually saving anyone anything. So like it boils always down to functions, and functions are the key composable piece. The fact that you can literally just go function call function call function is something that you can do in all of these frameworks. So it is the most primitive thing. Dot value or whatever turns the shape into something special, which it shouldn't. Oh, they do the knockout thing. Maybe with TypeScript this is fine. This was like the worst in the knockout ages. I'm not gonna like because without TypeScript, people would accidentally pass setter functions or getter functions into other functions, and then they get called an argument incidentally, and then just set the thing and screw the whole thing up. This was like literally the I ran away like this, like I was I told you that big app with create selector which we wrote it. It was written in Knockout, not in Solid or React or anything. I had tons of experience like that. And to be fair, don't get me wrong. The reason that app probably needed create selector and had that performance overhead is because we were using web components, right? In my infinite wisdom at the time, I thought we don't need real components. We don't need component model. We can use web components. We can use reactivity. This is going to be great. And then we just blew it up, adding web component, and now suddenly all our updates and props and our attributes are running through DOM life cycles. So like you better believe I had to optimize something. And what I chose to do was optimize our ability to propagate this change through the system, hence create selector. So another thing that we can thank the web components community and web components for in general. They've definitely innovated me in the past to build things that are more performant. Probably not the way they intended, obviously. I mean, they're the same. As I said, web components also the reason I created a framework. I was like, oh, stuff's built on the platform. It should be really easy to create a JavaScript framework. Or like, I wasn't even trying to create a framework, if you so to speak. I'm just trying to build something. So, I mean, web components are great. They definitely let you learn how to put you in a position where you get to learn how to make things more performantly. Yeah, yeah, that was a very long time ago. Were you even around, or you just remember me telling you about that at that point? Yeah, I mean, Knockout's great. The funniest thing is, I mean, I don't know, like the reason we were getting here is because we were looking at the JS Framework benchmark. And the reason we're looking at the JS Framework benchmark is I wanted to actually show everyone something here that they may or may not be aware of. While we were sitting here looking over the performance pieces of this, and you're going to see that, and I think regulars to my stream are aware of this already, you're going to see that up at the top in this range of things that is basically interchangeable with each other there is Vue RX JSX, Knockout JSX, MobX JSX. What are these libraries here? And do you know what these libraries are? These are libraries that I wrote using the varying reactive system, using DOM expressions, using the exact same uh, essentially renderer that Solid uses. I made one for Preact 2. I just didn't publish it at that time. So this whole 5 years now, under the radar, this Vue RX JSX has been sitting here right at the top. Do you know what this is, basically? I created Vue Vapor 5 years ago. It's just been sitting here. And don't get me wrong, Vue Vapor is faster, apparently. So I mean, you can see it is actually faster. The biggest difference between DOM expressions and Vue Vapor, I imagine, is that DOM expressions API shape was built with Solid in mind, so the wrapper is less optimized slightly to fit the shape of what Solid's API is versus Vue's API. But as I wrote this in over a weekend kind of approach, and I was always impressed with Vue because Vue's faster than Knockout. This is so funny because if you use actual Knockout, it's like back here beside Quick or Alpine, or where is it? Knockout, yeah, right here. Ember, all the grades. But if you remove the renderer and just use the reactivity, Knockout, is pretty swell. Where is it? It's right here. So this is Vue. See, look, Vue JSX Vapor is actually still behind the DOM expressions JSX. So maybe our JSX compiler is slightly more optimal, but it's probably just the same thing. It's like 0.2 apart. It's within variance, probably. Yeah, I wrote the Preact one in stream. So I was thinking, I was like, could we just update this to alien signals and see if it makes any difference? Like, would that be something fun to do? Like, because would that? I mean, I guess this isn't even alien signals version of Vue Vapor. Like, I wonder if that would cause some big movement on this chart. I mean, that was something I was thinking about. Because you got then again, I was looking at this and thinking about how old is this anyways? I wrote. Do you want to know when I wrote this and why I wrote this? I mean, it's petty now, but in a sense, but I worked really hard early days with Solid trying to promote the idea. Now it's funny that we have Svelte 5 and we have Vue Vapor, which are basically very, very similar in concept. But when I talked to the developers like Rich and Evan back in 2020, they basically told me that that's interesting, but there's a reason we do things the way we do those things, right? And I mean, I get it. It's fair, but I was reading an old article I wrote and I came across this the other day. Sorry, not this. Where is it? Not the selector. Sorry, this is different. What's this? Sorry, give me 2 seconds. No, this is not what I was looking for. These solutions, yeah, no. Yeah, this is him just saying that he's agreeing that the create selector is not benchmark specific. Okay, yeah, this isn't what I was looking for. Sorry, give me 2 seconds. All right, this is what I'm looking for. Back in May 2020, when Vue 3 was released, I asked Evan, I'm like, I'm unclear why you stayed using a virtual DOM after those changes. You alleviate a lot of the need for it once you break things down that way. Sure, diffing, there's a virtual data representation of sorts, but hardly need to do a full down, top down path, even if you skip parts. Basically, when Vue released Vue 3, they had an opportunity to make a change because they were making already a huge change with the composition API. And Evan's answer at the time was because Vue allows you to write manual render functions and mix them with template-based functions, giving up VDOM, giving up an important capability for advanced use cases where logic expression is more important than a bit of performance. I wonder if that's still the perspective now. It would be curious to know, because yeah, I did not have very much success. It's kind of funny. Again, I don't know if Solid would have ever gone to 1.1 if Rich or Evan had actually, been like, oh, this is really cool, we should do that, But I mean, I don't know what I was expecting either. So I mean, I'm glad to be here regardless. But it's been a very kind of interesting experience, kind of watching this progression of the frameworks kind of slide into this zone. I mean, yeah, I don't know. It's kind of funny. Knockout now is getting kind of heralded like 15 years later as like the thing, there's like, yeah, Knockout was doing this 15 years ago. Why did we all lose our way? And it's but like, try and find someone talking about Knockout back in 2018 or 17 or 19 or 20 or 21. Everyone these days is very quick to say like, oh yeah, Knockout was right all along. But like, there was like 7 years in the middle between like 2014 and 2021 where literally no one referenced Knockout. Yeah. Five years ago, no one used Signals and no one knew about Solid. Now everyone uses Signal, no one knows about Solid. Oh, well, I at least we reached the right people. The people that were able to actually implement the signals in their respective libraries. Yeah, React was sucking up all the air in the room at the time. But even in the alternative space, like when Svelte was released in 2016 or Vue in 2015, they could have been like Knockout, but they didn't. When hooks were released in 2018 and React were like, look, we can use primitives, they could have chosen to be like Knockout, but they didn't. Right? They that's when like they're like, oh yeah, we can use like Vue. Svelte 3 came about, and Vue was like started thinking about the composition API. In 2020, when I reached out to both Evan and Rich on Twitter, they could have looked at Knockout, but they didn't. But in 2025, everybody's Knockout. So, yeah. Yeah, I mean, it depends on where you're sitting. Like, Knockout was not as popular as jQuery, but the funny thing that kind of gap by is there was a whole period between jQuery and React, ironically, 7 years, which is the Solid. On my birthday this year, I had an amazing birthday gift that it'd been as long from when I open source Solid from the difference between jQuery and React. But there were other solutions at the time that were actually, how should I put it? Doing the declarative stuff. Knockout was one of them. Knockout came out before Angular or Backbone. It just wasn't as popular. But it was still a thing, right? I mean, my crate selector story was from 2018 ish. I was working on Knockout in production for 9 years. I used Knockout at one company from 2012 to 2019-ish, 2020-ish. Actually, they were still like on 2020 in production while we were doing the React rewrite. And then I'd used React Knockout for about 6 months at my previous company. Anyway, I don't know. I mean, we got some topics to cover. I mean, we could go in and we could set up the JS framework benchmark definitely, and see if Alien Signals does the thing. I mean, I think we have everything we need. I think the most interesting thing is that Alien Signals has effect scope, which means if you've ever seen my Vue RX JSX implementation, I actually have to invent ownership scope to inject it into it. And to be fair, now Vue probably has ownership scope. So the problem is maybe too much has changed that it won't be comparable anymore. Because like the problem is when I wrote this, Vue didn't have ownership scope. So I like untrack, pause tracking, reset tracking. I actually had to create ownership scope, create my own global context, and then make effects and memos that actually re-injected the ownership scope. And basically with all this extra cruff, that implementation with Vue was still basically right at the front of the list. So, and with Vue's old reactivity system, like before Alien Signals, before they even updated the performance, before they did basically anything. So I don't know. I'm tempted to do it because I was on the JS framework benchmark the other day, and there was an issue open here. It goes add Alien Signals to the test. Yeah, I mean, there's a want here, right? We can definitely do this. Yeah, I mean, we can basically, if Alien Signals already does self-releasing, we could probably just clean up this whole implementation. Maybe this is worth hacking on. Sorry, not solid suspense demo. Let me see if I have it locally. If I haven't installed JS Framework Benchmark locally, this might actually be a pain to set up for the first time, unless that's like what people care about to see on stream. And it doesn't look like it. Do you remember my computer got what? Let me double check. I ended up talking more about some stuff than I was planning to. Let me look at development. Do we have JS Framework benchmarks? Signals solid. No, this looks like a brand new computer that doesn't have anything on it. Why? They have vanilla JS signals with TC39. Sorry, is that in here? All right. Well, I mean, I can start git cloning stuff down. Let's see here. Why is this URL? It's so funny that this is the URL in the. All right. What do we want? We want not JS Framework benchmarks, of course. Okay, we want JS Framework benchmark. We want. What else do we want? I did update it in January, which isn't bad. We want, sorry, it's so funny. Clone, we want Vue RX JSX. See, look, I still have access to the repos from that startup that I was talking about. Not solid. Vue RX JSX. All right. It's in keyed? Okay. Let me. Oh yeah, Vanilla.js signals. Yeah, but it's a 7.7.2 implementation. But I mean, this is one of those things that I love seeing is like when you add something like signals, you make your app slower. It's science. It's only if you can remove the overhead of something else that it makes sense. So obviously, if your baseline is Vanilla.js and you add signals to it, it's going to be slower than just Vanilla.js. If you have React, you add signals to it, it's going to be slower than just React unless you change how React renders. If you add signals to Preact, it's going to be slower than Preact unless you change how Preact renders. And in the case of this benchmark, since it only impacts Preact's ability to render in like one or two places, it actually net is slower than Preact classes. So like the thing is, it's always kind of hard to tell, but like there's a different scale of optimization. Like, do we think, like if you look at Vue here at 1.27, and then you look at Vue Vapor over here at 1.10, 0.17 improvement, like 17%, say, performance improvement. Do we expect alien signals to make as big of a difference as jumping from normal Vue to Vue Vapor? No, we don't. The question is, can making your reactive system double, triple, 3 times faster have any impact on something that's render constrained? Where's backbone plus signals? Yeah, that's what we need. All right. Okay, so let's see if we can do this. I guess the first thing is file open. Let's get out of here and look at, let's see if we can get the JS framework benchmark running on just like a couple little things. This is always fun to do occasionally because we'll worry about ZSH later. Okay. This is always kind of fun thing to do because honestly, getting this set up for the first time for a lot of people is actually kind of a pain because I have to make sure that I don't run the wrong command, because when you npm install, it ends up like it might install like everything. Let's see if this is what we want. Let's hope it doesn't install every framework. Did it actually work, or like, is it actually that fast? Okay, that's fine. And then we want to go into WebDriver TS and npm install in here too. And then WebDriver TS results. Let's npm install in here too. Yeah, I mean this is not, I think in all I'm going to need like 3 windows here. I'm going to need the main one that runs the server. So if I go npm start, this should start up this server on 8080. I'm going to need to go into a couple of the frameworks and build them. For the purposes of our test, we probably want to pick a Vanilla.js framework. So we'll go keyed, not broken, frameworks, keyed, vanilla. What's the fastest Vanilla.js implementation right now? Vanilla.js Lite. Looks sweet. Vanilla.js 3 is pretty close too. Any characteristics that are different? Yeah, okay, we'll do Lite. Vanilla.js Lite. npm run build prod. I don't know if Vanilla needs it. Okay. What else should we need? We need probably Vue Vue. Sorry, what am I doing? Okay. We need Vue Rx JSX. We should definitely install this one. pm run build prod. Beautiful. We should have like a third point of reference for this to be worth doing. I mean, we don't need it. Let's see if we can get Vue Vapor. Yeah, let's use Vue Vapor as a third point of reference and npm install that. Okay. And now that we've built all our frameworks for now, we need one last window to actually run the tests. cd web driver ts npm run bench, I think. Okay, what are we missing? Okay, let's see if we can build here. It's a build. Compile is called. Is that it? Now can we bench? Okay, yeah. I mean, it's busted, but okay, that's fine. So then I can go like -- framework vanilla light. Is that, let's see, frameworks keyed vanilla JS light. What if they're gonna? They've changed some of the stuff over time. So what do we want? Vue Rx JSX and Vue Vapor. Okay, yeah, it did not match any of those. So I think what I actually have to do is put keyed in front of each one. Keyed. Sweet. Okay. Okay, so we had the benchmark working. I don't know if we want to run the whole bench suite right now. I think let's worry about that later. If we need to, we'll worry about that later. I just wanted to see that we have this working. Okay. So then the next thing we need to do is see if we can make a new version of Vue RxJSX, basically, which, let me see. I'm wondering if I can just kind of go in here and just like swap out the code in the yeah. So we just swap out this dist folder with whatever we build in the repo, and we should be fine. Okay, yeah, let's do it. Seems straightforward enough. I'll just like make a copy of the folder. It'll make our life easier. File. This is an old version of DOM expressions, but I think it'll serve for our purposes, because basically what we want to do is we want to replace Vue reactivity bigger than this with like, what do we call it? It's just alien. Is it just alien signals? What version is alien signals on? 1.0. we'll just assume that we can add it at 1.00. Okay, sorry. You can tell I haven't coded up on this stream on stream because my text is way too small. I'm sorry. I'm sorry, everyone. Let's just get this going. Or it's npm. All these old repos. npm run build. Does it still work? Oh, it's because I used to